Yeah, greetings everyone. Today, basically, I want to take you through on how to do a pre-processing in order to enhance, the performance of our model. So this basically can definitely help us to make sure that like our data is really clean before we feed it to our machine learning. So the first thing that we're gonna do is that we are definitely gonna import all the libraries that we're gonna need so far, in order to carry out this process. So let's try to import pandas first. Let's import pandas as pd import numpy as np. We're gonna also import matplotlib py plot as plt. We're also gonna import cbond as sn. Let's also import uh, the knn imputer from sklearn dot impute import knn imputer. Yes, so I think yes, we actually need this also actually for our preparation step. But let's try to import one more thing. I think we also need that one because I actually want to show you all the necessary preparation steps that we actually need to do. I mean, before we start training our model. So let's also try to import label encoder, which can definitely help us in order to encode some of those object values into integers. So we're gonna say we are gonna also import it from sklearn. So sklearn from sklearn.preprocessing, we're gonna import label encoder. So basically, these are some of the libraries that we need, and this libraries is really gonna help us, for a very good pre-processing. So the pandas basically definitely help us to, I mean, read the data that we have. The numpy basically is also gonna help us to work on numerical values, and then actually, numerical values and arrays. And the matplotlib and the sequence will actually help us in order to, have the necessary plots that we need or to visualize the data that we have. We also have like the knn imputer, which is actually imported from sklearn. This knn imputer also plays a very significant role. It actually helps us in order to solve missing value issues. So in case if you came across any other form of missing values, but if you don't come across any missing values in our data, we don't have any missing values in our data, I will still show you how exactly to solve these missing values using the knn imputer. So far, in case in your future work, if you came across any data that actually has missing values, you can simply use it to resolve the issue. And then from there we also look at like how also to encode some of those some of the objects so far, so that we can actually transform it from being object to an integer, so that we can actually use it to train our level our machine learning model. Basically, if you don't do this, we'll have some difficulties so far in training our model, because our model basically gonna understand digits more. They understand digits so far compared to using these objects. So hence basically we have some difficulties, which means we have to use the label encoder in order to encode those objects values to numerical values. So, and we're going to do that, and we're going to show you guys how exactly that can be done in a very simple way. Now let's try to read our data. Let's try to read our data and then see how exactly our data looks like. So what we're going to do is that let's store our data in a variable named df, which is equals to pd, because we're going to use pandas to read our data. We actually import it as pd. So we're going to pd dot read underscore csv, because we're dealing with a csv file. So always take note, use underscore csv. So open bracket. Then we actually need to uh, put the path of our data. As you can see, this is our CSV file. We're going to use this breast cancer CSV file. The other way, you can actually click here and then copy the path of the data. If you want also like, you can also like write cancer the same like the way you name it cancer.csv, but make sure it ends with CSV, and then also enclose it with either a single quote or a double quotation. So actually it's fine in either ways. But like if you copy the part directly from here, and then you paste it, like let's use a simple Chrome, let's paste it and we paste it here. When I run it in this way, it's actually gonna give me an error, because what I have to do is that Python will actually, run through certain. What you have to do is that you have to write some escape sequences. This actually definitely, help us in order to escape, such, uh, errors that we might actually face in future. So let's just try to run this part first, and then after running that, if you want, we can also run this. But let's just try to print it. Let's just hit df and then try to print our data. So this is basically the data that I have. This is our data, and you observe that basically our data basically has 16 columns and 4024 rows. So this is what exactly it has with 16 columns. So if you look at this data properly, you look at the status of data, you can look at the structure of the data. We have some objects, and then we also have some integer values here. But let's look at this clearly. So this is the status. So basically this is gonna be our level as well, I can say, but we don't actually reach at that end yet. So but when we reach at that part, we will definitely explain, and we're not gonna cover that today here, how exactly we're gonna implement the ML model. But let's, for the sake of learning, let's say this is the level status, and the other we have either alive or dead. So these are some of the things that we actually need, for our model. So these are the level. So what do we have here? But let's see, how about if you just wanna visualize the first 10 rows in our data set. What you're gonna do is that you use the dot head functions and then open bracket, and you insert uh, the number of rows you want to visualize, which is 10, and this is actually going to print out the first 10 rows in our data. But how about if you want to print out the last 10 rows in your data? What you're going to use, you use the tail function. So the tail, so if I hit this, this is actually going to print out the last 10 rows in our data. So this is what exactly, or this how exactly you can simply read your data so far. Very easy and straightforward. Now the next thing is that let's just try to check the information that we have in our data, which is very significant as well. We have to understand how our data is being structured before we actually move to any other step. So in order to do this, or to check how the data or the information in our data, we also gonna use the info function. Now we're gonna use df.info, and yes, so df.info, this is actually gonna print out all the information we actually need to know in our data. And then from here we can actually see a lot of things going on here, and you observe that basically we do not have, like, we actually has 424 yeah, entries as and you observe that basically, looking at, we don't have any null count values here, and you observe basically we also have integers and also objects values here, because those are the two values that we don't have any float values in our data here actually. Now you observe we have only 5 integer values, and we also have 11 objects values so far. Yes, so these are some of the things that we have, that for each column. So because this actually, highlighting the columns, we have 16 columns, and we have 5 integers values. We also have 11 object values so far in this data. Now the next thing is that no need to check the shape, I can say, because we already have the same there. I don't need this one because it's already been visual. I don't want to be redundant. So in reading the data, we already visualize the shape of the data, which actually has 4024 rows and also 16 columns. We already know that. So the next thing is that let's try to check for missing values. Let's try to check whether we have missing value in our data. And in order to check these missing values, what we're going to do is that we're going to say df dot is null function, because it's going to help us to check the missing values in our data. So dot sum, we're going to check those missing values. We're going to use the dot sum function so that we can count, check the count, how many values actually do we have missing. But let's try to store this in a variable, like missing value count, or missing, yeah, let's say missing, yeah, no need to check it, put it in a variable. If you want also, you can also put it in a, or store it in a variable, but not necessary in my case. Let's just look at the missing values that we have. And you often basically, we don't have any missing values here. There is no missing values. All the columns basically, we don't have any missing values at all. So basically our data basically is actually clean at this stage, but we also gonna look at other steps as well to see whether we'll still have the data being cleaned as well. So since we don't have any missing values here, so in my case basically I actually don't need to use the KNN inputer in order to to resolve the missing value issue, because I don't have any missing value issues here. But for the sake, in case of feature work, you came across some of your data set having missing values, I will show you how exactly you can definitely resolve this matter in a very simple way using the KNN inputer, which can definitely helps in order to resolve these issues. But what we're going to do is that let's say for instance we have more than one columns that has missing values. Yes, how exactly can we definitely resolve this? I'm gonna show you guys here how exactly we can definitely do this. To loop through all of those columns using the for loop, because the for loop basically can definitely help us to work in multiple columns at once. So rather than actually doing it one by one, so actually gonna make our work much easier. So we're gonna use the for loop. So we're gonna for I in int we have our this square bracket, and we have also uh, our quotations, that is a single quotation. Now let's look at, now let's say like we have missing value. For instance, let's say it's an example though, we don't have any missing value here, but for instance in your case in FeatureWorks, if you came across the data that has missing values, so that you'll be able to resolve. That's why I'm doing all of this thing. Now for instance, let's say two more archetypes actually has a missing value. Let's copy this column and then paste it here, and then close the column comma, and then let's say also region node examine also has a missing values. Let's copy this as well, Control C, and then paste it here, and then close it, and we close our square bracket. Okay, so we have our column, and then hit enter button. So now when we have this, because we actually want to use, but remember actually before you proceed, you have to initialize this KNN input. We don't initialize it, so we have to initialize it first. We say input, we're gonna store it in a variable named input equals to KNN inputer exactly. So we're gonna initialize. You have to initialize it. If not, you won't be able to proceed, because it's a very necessary steps. So the next thing is that we are definitely gonna say our df I here will be equals to input dot fit transform. That fit transform is the function that we're gonna use. Then we have our own bracket, we have df, we're gonna have I, and when we have this basically, if we run this, what it does is that it actually tries to resolve those missing value issues. So hence basically you have missing values, all of those missing values basically will be resolved automatically. Sorry, this part it shouldn't be v, it should be two more. It's a mistake, sorry, I'm just saying it right now. I just wanted to paste it, but I mistakenly hit only v. Yeah, so this what exactly we get. So when I run this, this actually is gonna resolve the missing value issues on each of the columns basically that you have detected missing value. So using this function can definitely do it for you in a very easy way. So this is how exactly you resolve a missing value issue. But next thing is that let's try to look at duplicates, whether we have any duplicates over in our data as well, which can definitely help us in order to resolve a lot of issues. Now, checking for duplicate, let's just try to, store it in a variable. Let's say, now, let's just try to look at how it is. Now, in order to resolve this duplicate issue or to check for duplicate, what we're going to use is that we're going to use df dot duplicate, duplicate dot, have a bracket, dot sum. So with this function, it's definitely going to help us in order to get or to give us a count of all duplicates that we have. But let's definitely store it in a variable name like duplicate count. Store it in these variables and then see what we're going to have at the end of the day. And then from there, let's print it out. Duplicate count, and let's see the duplicates that we have here. You observe that we only have one duplicate at the end of the day, so this is a single duplicate that we have. But how exactly? So we just want to see now. How about if you want to see like the rows actually that are duplicated? What exactly now? What we're gonna do is that to have a visualization, you look at these rows that have been duplicated. We're gonna use df df dot duplicate. Okay, df dot duplicate, and then we have also keep equal to false. So if we have this, we're gonna print out, the rows that have been duplicated. As you can see, row 213 and row 436 basically are the rows that actually appears twice in our data. So we don't need this. We just have to drop one of these rows in order to focus on only one. So we don't want these rows to appear more than once over in our data. So this is actually not good for our model. So in order to resolve this issue, we actually going to drop one of these rows. So what we're going to do is that we are actually going to use we're going to say df dot. Let's store this in a variables. Let's say df here will be equals to df dot drop duplicates. We have the suggestion here. Drop duplicates. This one actually we're gonna have. We have df dot duplicate keep, so that we can actually drop any other duplicates as well in our data. So once we do this, you observe that we're gonna drop all the duplicates that we have. So let's run this. And then yes, so let's confirm whether this duplicate actually has been dropped successfully. Now what we're gonna do is that let's check for duplicate again. df dot duplicate created dot sum. Let's try to check whether we don't have any duplicates now. So all the duplicates basically have been dropped successfully. So that part also has been resolved. So the next thing is that let's try to check for outliers, which is very significant. In order to do this, we are going to try and then at least visualize the data using a box plot, in which we're able to see which actually, or which of the columns basically has outliers so far, and we're going to try to resolve these outliers in order to enhance our model performance. So in order to do this, because since we actually want to plot multiple plot, but we only have to focus on the numerical values, or the columns with integers, the columns with numbers. So with object values, basically we're not going to plot this one for sure. So hence basically plotting, we're not going to deal with the biggest columns with numerical values. So hence basically in order to do this, let's use the for loop so that we can actually loop over and over to all those columns. For df, we are only going to select specific data types. So select d types, open bracket, includes we're only gonna select the numerical values so far, number, yes, so this is what we need, and then dot columns. When we do this actually gonna focus on only the numerical columns instead. So what's going on here? Why do we have this error? Okay, so yeah, done yet. So this is what exactly we're gonna do. So the next thing what we're gonna do is that we are actually gonna plot the box plot using sn, because we import c1 as sn. We have box plot because we need the box plot, and then from there we open bracket. Let's store this in data, df comma, and then x here will be equal to I. Those are some of the stuff that we need, and we have next thing, plt does show this what excel we need in order to actually deal with our plotting. So basically, okay, it should be for I in, okay, so this was a little bit error, yeah, not a little, but I can say it was an error. So yes, so for I in df dot select the types include numbers as well. So dot columns, yes, and dot box plot data. So let's just try to see what excel we're gonna have here or to visualize the outliers. And age, yes, age is actually cool, we don't have any problem with that. And nevertheless, I'm sure we actually gonna drop it so far. When we actually trying to split our data into features, and also keep living with these features and also levels. So hence age is will not be that much significance over in our analysis, I'm sure of that. So basically we not actually use that column, yeah, at some point in time. I don't know what might be. So basically we're also going to look at the tumor size. The tumor size basically, yeah, we have a lot of outliers as you can see, and then you look at also the region node examine as well. You observe that we also have some outliers. Region node positive, we also have some outliers. and also survival months as well. We have just few outliers there. So we are actually gonna treat these outliers. We are actually gonna make a very good treatment for this one. But actually, you have to, I mean, also be very careful when you are dealing with outliers. If removing outliers might actually cause or give you some problems so far, in your model performance, or if it might lead actually to a very poor model performance, I can say it's better for you to, I mean, leave it like that, not to remove those outliers. But if you observe when you remove the outliers, it actually enhance your model performance. Yeah, sure, you can actually go ahead in doing so. Now, the next step is that let's look at how best we can actually resolve this issue. Uh, of this outlier issue. So the first thing that we're going to do is that we actually gonna create a functions and then try to, I mean, compute the lower whisker and also the upper whisker, and this thing will definitely help us in order to, I mean, deal with or to resolve this outlier issue. So the first thing is that let's define a function for us. First def is equal to, let's say, outlier treatment. I name it as outlier treatment as well. So this function will actually call a variable column named columns, and then we have our columns, and then yes, the next thing is that we define our q1 and also q3, and then we also gonna compute percentile uh, the percentile of this. We have column comma, we gonna store this, that is the 25th and also the 75th percentile. These are some of the things that we are going to complete as well. So basically, now the next thing is that we actually gonna, I mean, find the difference between these two quartiles. So our IQ will be equal to that is your Q3, our Q3 minus our Q1. So this is what exactly we get. So in order to compute our low whisker here, this will be equals to like the low whisker will be equal to like q1 here, minus 1.5 multiplied by IQ. So the same thing also for our upper whisker here will be equals to q3 here plus plus 1.5 multiplied by q. So and then from there we actually gonna return these values. We don't need to print it out, so we're gonna return the low whisker comma and upper whisker. So you have to be very careful actually when you're using this return function. You make sure that like it is still indented, because if you remove this indentation, if it's come out of the function, it actually gonna give you an error. And I'm sure some of you guys already know how to, I mean, deal with functions. So we have to return this value. Now the next thing is that let's try to, I mean, work on this, because since we actually want to, I mean, resolve the which of the outliers issues, and we are dealing with multiple columns, we're going to use the for loop, which is going to make it easier for us. Now for I here, for I in for I in yeah, because since we actually bought the other basically is actually the numerical values. Now let's use just select d type for I in df dot select d times bracket include numbers, include number dot columns, and then enter. Once we do this, so sorry, something is going wrong, and then we hit the enter button. So once we do this, the next thing is that let's try to, I mean, store this low whisker, because we actually return the values. So when you return, you always have to store it in a variable. So let's just start to store it in the corresponding variable is equal to. Now we're gonna say yeah, we're gonna call out the function, and the function was named as outlier treatment. In bracket we have the outlier treatment. And then thing is that what exactly this function is, because we actually define a variable called. So basically we actually gonna, yes, column is gonna hold a variable dfi. So this variable is actually going to hold, and then from there what we're gonna do next is the next thing is that we actually gonna set the condition as well, so that will definitely resolve this outlier issue. Now we're gonna say our df here I here uh, will definitely be equal to np dot where 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 sorry for that, sometimes my keyboard, where df here dfi where dfi here is less than, if it is less than the lower whisker. If it is less than the lower whisker, then we have to replace it with the lower whisker, else we actually keep dfi. So basically this what excel we need. So okay, okay, now the other thing is that if our dfi, we're gonna say dfi, we're gonna store it in variables. Dfi here is equal to dot uh, np dot where dfa dfi dfi is greater than upper whisker, then we actually gonna replace it with upper whisker, else we maintain dfi. So basically this is what excel we get. Now we'll run this and then see what we're gonna have. Yeah, this is order. Now let's actually verify. Let's just try to replot this box plot and then see whether we still gonna have these outliers visibles across. Now let's see what we're gonna have, just to confirm that this outlier issues has been resolved. But yes, age, yeah, and also tumor size, region node examine, region node positive, and so on. Actually, all of these things basically are intact, so hence basically the outlier issue has been resolved successfully. As I said earlier, you always have to be very careful when you are dealing with outliers. If it doesn't, if it's actually not working well with you, if it's actually not resulting in a very poor performance of your model, you can say it's better for you to leave it that way. So the next thing is that we actually have to, deal with some of the objects so far, so that we can to convert it to an integer or to a numerical values that can be used so far to train our ML models, because if not we will actually have some experience in training our model. Yeah, for XGBoost basically it has the ability that yes, you can actually import this encoder into that function. XGBoost version basically can handle this stuff very efficiently. But like in case for other methods so far, it's always very good for you to do some of the pre-processing steps, using label encoder as well, in order to enhance that or to ensure that you don't, run into any form of problem so far during training your model. So hence basically in order to do this, we already import level encoder, as you can see earlier on when we are importing the libraries that we need. So the other next thing is that we have to initialize it. Let's initialize name it, store it in a variable name encoder equals to level encoder. We actually gonna store it in this variable as well, and then we hit the enter button. Now the next thing is that since we actually dealing with more than one columns, we use the for loops for I here in because yeah, for I in, because we only have issues with the objects values, so hence basically we will look at deal with other. So for I in df dot d types, select d types rather, or dot select d types open bracket, and then we have uh, includes object dot columns. So this label encoder is only used on the object columns so far. So enter. So what we're gonna do next is that we are actually gonna fit this so far in our column. So we're gonna say like df so I here, this will be equals to encoder dot fit transform into, we have df high. So this all we need in order to resolve those issues. So basically that's done. So everything is being resolved now for that. So we can actually verify. Let's print our data again and then see whether everything is being converted. Yeah, you see everything is being converted to a numerical value. So after we don't have any objects here as well. You observe that basically all of these basically are actually integers, and this one actually is a float values, that is the two most height. Yeah, so yeah, we all have all our objects so far, they are all integers rather, so we are actually good to go. So everything is actually being labeled so far. You observe that alive basically actually giving a label of 0, and then yes, two most high, how do you call it, depth is actually given a level of 1. So basically this is the whole pre-processing steps. So if you have any questions so far that you want to ask so far, you can actually leave it in the comment section, and please you can also subscribe to this channel in order to keep me going, or to help at least to develop this channel to the levels we actually want it to be. So I'm gonna say thank you so much, and stay tuned, subscribe for the next video in which we're gonna implement different ML models that we're gonna use. We're gonna use this same data, so the same process data. We're going to use this model, this database, in order to train different machine learning model. So basically you have to stay tuned, and then make sure you subscribe, so that any new videos that we actually release, you will easily have access to it. So I'm going to say thank you so much, thank you so much once again. This is the end of this video.